All right, what's up, VLAP statistics students? We are in week 5, day 1, still working on unit 7. Today's topic is 2 sample T-procedures. We're going to look at both the T-interval and the T-test for situations where we have 2 samples. Okay, quick agenda. I just want to make a couple announcements about the AP exam and then what we'll be doing for the rest of the year. We're going to fill out the next row of the inferences for means review grid. We'll work through a question of the day. I'll go through the 2 sample T procedures, and then we'll wrap it up. All right, so our upcoming schedule, so remember there's 2 options for the AP exam. You have already made this choice. Please let me know if you do not remember what you chose. Remember, the in-person AP exam is at Central. It's on Tuesday, May 25th. It's at 11:30. You need to be in the library by 11:30. The test will go until probably a little bit after 3 o'clock. So please make sure that you are ready for that. Many of you also, Others may have selected the digital AP exam. Remember, that's Thursday, June 10th. You should have received an email from Ms. Armstrong late last week that went through some of those procedures. So make sure that you got that email. If you did not get it, please let me know. But do review the instructions in that email. I'll highlight a few more of them as we're going. I'll probably also send out either a Schoology update or an email about the AP exam. So let's kind of just see where we're at. So week 5, this is where we're at right now. We'll be working on the 2 sample T procedures both today and day 2. Week 6, we're going to get into Unit 8, which is the chi-square tests. I'll do a lesson on that. We'll also do a little bit of AP review. There is no class on May 18th due to the MCA that the 10th and 11th graders will be taking. And then week 7, we'll be doing some more AP review. If you are doing the in-person exam, your in-person exam will be during week 7. If you're doing the June 10th exam, then we'll have some review during week 8 as well. And then Thursday, June 3rd is the last day for seniors. Okay, send me an email if you need any more instruction on any of that stuff. Otherwise, let's move on. All right, so if you want to pull this up on Schoology, on Notability, the inferences for means review grid. Remember, we did the T interval for mu last week. So today we're going to fill out the T test for mu. And I'll do that kind of along with you. So the purpose of a hypothesis test is to test a hypothesized parameter. So in this case, our parameter is mu. So the purpose is to test a hypothesized population mean. All right, so we're going to be using X bar and S to run our test to, again, test a hypothesized population proportion. All right, conditions, couple conditions here. So remember, first condition, either random sample, or remember, it could be your data could have been collected from a randomized experiment. We do have a random sample. Next condition, 10% rule. I'll just kind of do it shorthand, write it shorthand as the 10% rule, but remember that your sample size needs to be no more than 10% of the population size. Third condition, remember, is that either n has to be greater than or equal to 30, or remember, there's a couple ways of meeting this condition, or you were sampling from a normal population, and then the third way is the box plot of the sample shows no strong skew or no outliers. All right, so those are your conditions for the t-test for mu. Remember our test statistic is T. So instead of a Z-score with a t-test, we are calculating a t-statistic. And that, remember, you take your sample mean, x bar, you subtract your null the hypothesized mu value from your null hypothesis. So again, that comes from your null. And then you divide by the standard error, which is S over the square root of n. So that's sample standard deviation divided by root n. Okay, so that is your formula for the test statistic. Remember how you calculate a p-value? So remember, we want to use the tCDF calculator function. So remember, when you're using tCDF, you cannot put in the mean and standard deviation. So you do need to use your t-value, your test statistic, as either your lower or upper bound. And then remember, you also need to use degrees of freedom as your third argument. Remember, degrees of freedom is n minus 1. And then the calculator trick is t-test, and that's from the stat tests menu on the calculator. Okay, so that is just kind of hopefully it helps you organize the some of those key features of your significance test for mu. Okay, so on to the next thing. So this is a question of the day. You are going to do this in Notability and then submit it to Schoology. This is a 4-step problem. I'll read it for you first, and then I'll give you a little bit of time to work on it, and then I'll run through the answers here. Okay, so consider 20 first-year resident female doctors drawn at random from one area. Resting systolic blood pressures measured using an electronic sphygmomanometer. All right. I think I said that. Said that right. So here's your data: 20 systolic resting blood pressure readings. So from previous large studies of women drawn at random from the healthy general public, a resting systolic blood pressure of 120 millimeters Hg was predicted as the population mean for the relevant age group. Is there significant evidence to conclude that female resident doctors have higher blood pressure than the general female population? Test at 0.05 level of significance. Okay, so go ahead, pause the video, work through that 4-step process, and then come on back for the solution. All right, welcome back. Hopefully that went all right for you. So I'm going to start by going through the problem. So the first thing that you should have done is type the data into your calculator to get x bar and s. So that's what I have here. I have this in L1. Oops. And then to get the mean and standard deviation, I go to one of our stats. So stat, calc, L1, and I get that mean value of 130.05, sample standard deviation of 9.96. All right, so move that to the side for the moment. So that's the information I wrote there. Oops, and this should be 19 degrees of freedom here. Alpha value is 0.05. So that I'm ready to start step 1, I will conduct a t-test for mu, where mu is the true mean resting systolic blood pressure for first-year resident female doctors. So I named my procedure and I identified my parameter. Next, then I need to write my hypotheses. So I'm trying to show that these doctors, female doctors, have a higher blood pressure than that general population. So my alternative hypothesis is that mu is greater than 120. So then that null hypothesis, I'm going to assume that it's the same. So I'm going to assume that these doctors have the same blood pressure as the general population. I'm trying to show that it's higher, maybe due to stress or just kind of some of the things that go along with being a doctor. All right, so that's step 1. Step 2, then we test our condition. So random sample, we did have that. N equals 20 is likely less than 10% of the first-year resident female doctor population. So we can assume that there's more than 200 of these types of doctors in this area. Now my N value was small. It was 20. It needs to be over 30. So I did need to check the box plot. So I drew it here. Let me just remind you how to make a box plot. So we go up to stat plot, turn this one on. I'm going to pick the box plot with outliers. And then remember, make sure it says L1. And then if you hit zoom and then zoom stat, which is number 9, it'll make a good window for you. And we can see it does have almost perfectly symmetric, no outliers, no heavy skew. So I said the sample box plot shows no strong skew and no outliers. So that these other conditions then are met, so we are able to proceed with step 3. All right, so step 3, you just have to put down your t-value and your or your p-value and your t-test statistic. So here I use the t-test function. So it's stat over to test, t-test. And I had my data here, so I'm just going to leave this as data. My mean was, my null hypothesis was 120, so I put that in there. L1, and I am doing an upper-tailed test, so a one-sided test. I'm going to hit here and then go to calculate. And I can see there is that t-value that I reported and my p-value, 1.192 times 10 to the negative 4th. So again, that's what I have here. So that's all we have to do in step 3. Usually also write down degrees of freedom. I did that at the beginning of the problem, so I took care of that there. And then my step 4, so the p-value is certainly less than 0.05, so I can reject the null, giving me significant evidence to conclude that the true mean resting systolic blood pressure is greater than 120 for first-year female resident doctors. All right, so that is that 4-step process for this problem. So hopefully that went all right for you. So make sure that you get that question of the day submitted to Schoology week 5, day 1. All right, on to the next thing. All right, so we're going to start talking about 2 sample tProcedures. So I'll just give you a little information first, and then we'll go through the processes. Okay, so we have 2 of these 2 sample tProcedures. So we have the 2 sample t interval for mu1 minus mu2 and the 2 sample t-test for mu1 minus mu2. Remember, we have done these for a difference in proportions. So today we're going to do this now for the difference in population means. So to estimate the difference between 2 population means, we construct a t confidence interval using x bar 1 and x bar 2 and s1 and s2. Then the 2 sample t-test for mu1 minus mu2, same thing. To test if there is a difference between 2 population means, we conduct a t significance test using x bar 1 and x bar 2 and s1 and s2. Okay, so what I'm going to do is go through the 4-step processes. So I kind of have these running parallel to each other. So I have the t interval here, t-test for here. So I'm going to start with step 1. So step 1, for an interval, name procedure and identify parameters. So notice it's plural. We do have 2 parameters here, so we need to define both. So I kind of modeled that here. I will construct a 2 sample t interval for mu1 minus mu2, where mu1 is the true mean, and then whatever you're measuring, and then mu2 is the true mean, again, whatever you're that second thing you're measuring. So I use the subscripts 1 and 2 here. You can use letters for your subscripts. So if you have some meaningful letter to use instead of a 1 or a 2, you can certainly do that. And I'll show you that when I go through the example. Okay, so that's for the interval. T-test, also pretty similar. Procedure, parameters. Remember, the third thing you have to do, though, with a t-test is write hypotheses. So I basically have the same thing here. I will conduct a 2 sample t-test for mu1 minus mu2, again, where mu1 equals and mu2 equals. So make sure you define that. Also make sure that you can see what your subscripts stand for. So then my null hypothesis is going to be mu1 minus mu2 equals 0. Remember, that's equivalent to saying mu1 is equal to mu2. Usually I do this where I pick the larger sample mean to be from the first population. That way I get a positive difference. You don't have to do it that way. I just find that it makes it a little bit easier. And then your alternative, remember, you have the 3 options. Your difference is either greater than 0, so that mu1 is bigger than mu2, less than 0, which would then say mu2 is bigger than mu1, or you could do a 2-tailed test where you have a not equal to 0, so just where you're showing that there just is some difference between those parameters. Okay, so that's step 1. Let's move to step 2. So again, step 2, and again, I have the t interval over here and the t-test over here. These are both exactly the same, right? So I just put them in both places, but verify your conditions. Both samples are random, or both data sets came from a randomized experiment. You will see these used in more experiments, so you may have this randomized experiment. Second condition, both samples are less than 10% of the population sizes. And this is if sampling is used, and specifically sampling without replacement. So sometimes if you're doing an experiment, you may be using randomization, and maybe you are using randomization of volunteers, so you actually didn't have any sampling. That's okay. Sometimes this 10% rule doesn't apply. So there may be some problems where you're working through this procedure and you don't have to check that 10% rule. And then the third condition, your two sample sizes have to be greater than or equal to 30, or both samples came from a normal population, or both sample box plots show no heavy skew and no outliers. So there may be some scenarios where you have to make a box plot for each data set, and again, look for that lack of skew and a lack of outliers. Okay, so that is step 2. Step 3, again, we have t-interval over here, t-test over here. So you got to carry out the procedure. So with a interval, remember you need a critical value, and then you need to use the formula. So t star can be found using, so remember the critical value is t, so we usually write it as t star, can be found using inverse t, using the tail probability and the degrees of freedom. So that's usually what we do. The thing is now when you're dealing with two samples, the degrees of freedom formula becomes much more complicated, and very rarely are we actually going to do your degrees of freedom by hand. We're mainly just going to be using technology, and the technology we're going to be using is 2samp tint, and that's actually how we're usually going to be finding the interval as well. But I do have the interval formula here. You take the difference of your two sample means, plus or minus your critical t-value, and then times that standard error formula, S1 squared over N1 plus S2 squared over N2, and then square rooted. So again, we are mainly going to be using technology, and that can be use both the critical value and the interval formula. Okay, and then the t-test, your test statistic, this is this formula. Numerator is x bar 1 minus x bar 2 minus mu1 minus mu2, and remember that this number is usually 0. That comes from your null hypothesis. I still put it in there because that's where the center of your sampling distribution is going to be. And then notice we have the same standard error formula on the denominator. So that's your test statistic. You always want to report that. Again, we're going to be usually using technology to find this. And then the p-value can be found using t-CDF, using lower t-bound, upper t-bound, and df. But again, the df formula here is complicated, so it's best found using 2samp t-test on your calculator. And I'll show you that in a few minutes. Okay, so that's step 3. And then step 4 is you do your interpretation. So again, we have the t-interval interpretation over here, t-test over here. So you say, to interpret in context, I am C% confident that the interval blank to blank captures the difference in means between population 1 and population 2. And again, just make sure that you have this in context. It's always important to address your context. And then if you're interpreting the t-test, remember you compare your p-value to alpha. That decides whether you reject or fail to reject. If you reject, there is significant evidence for the alternative. It's usually saying that one population mean is bigger than the other. Or there's, if you fail to reject, there's not evidence for the alternative. Okay, so those are your 2 4-step processes for both the 2sample t-interval and the 2sample t-test. All right, so I'm going to go through a problem with you now. So does eating more red meat promote weight gain? So a longitudinal study among nurses tracked 2 randomly selected groups. The reference group maintained their initial amount of red meat consumption. So there was just a less than a 0.15 servings per day change, and a group that increased the amount of red meat consumed. So this is a change of more than half a serving a day. So we have the reference group and basically the kind of like the experimental group. I'm calling it the meat group. So the change in body weight in pounds was measured over the course of the study. So this is a multi-year study. So here is the data. So for the reference group, for these nurses, the average weight gain was 7 pounds over the course of the study, with a standard deviation of 13.6 pounds, so pretty large standard deviation. And the sample was also very large, so over 12,000 nurses. I'm using the subscript R for each of these. So X bar sub R, S sub R, and R for reference. Okay, and then if we go over to the group that changed their consumption, so these people increased the amount of meat consumed. So I'm using M as the subscript for meat. And X bar M is 9, S sub M is 16.1, N sub M is 35, 31. So it's a fewer people in this, but also a pretty large sample size. So is there significant evidence to conclude that the mean weight gain is higher for the meat group, right? So does increasing your amount of meat consumed also increase that amount of weight gain? And we're going to use 0.05 as usual. All right, so what I'm going to do is just move into step 1. So I already have my information all written down above there. So I will conduct a 2-sample t-test for mu sub m minus mu sub r. So that's the order of subtraction that I'm going to do. So this is going to be like my first group. This is going to be my second group. I'm trying to show that there's going to be a positive change here. So then I define mu sub m and mu sub r. So the true mean weight gain for nurses who increase their red meat consumption, that's mu sub m. Mu sub r is the true mean weight gain for nurses who maintained their red meat consumption. And then moving to my hypotheses, my null hypothesis, mu sub m minus mu sub r, is equal to 0, so that their weight gains, we're assuming that their weight gains are the same. And then what we're trying to show is that the mean weight gain for the meat group is larger than for the reference group. So that's step 1. Give you a second here just to take that in. Step 2, we have conditions. We did have 2 random samples. Now these samples are pretty large. So I said they are likely less than 10% of their population sizes. So if you were just to tack a 0 onto those, we'd be at 122,000 nurses. I'm not too familiar with that, but I would assume that would probably be an accurate number where this would be less than 10%. And then same for the 35, 31 number. So we'll assume that condition is met, and then obviously they're both greater than 30. So our conditions are met here. We didn't have to consult the box plots or anything. And then what I did is I went in and used the 2-samp t-test. So I'll show you that now. So I'm going to go over to, so again, stat, tests, and then I'm going to pick the 2-samp t-test. 2-samp t-test. All right, and then I'm going to go back. We were given stats, so I'm going to hit stats for my input. So my X bar 1, I'm going to let this one be the meat group. So 9 for a mean, 16.1 for S, 35, 31 for that sample size. X bar 2 is going to be 7, 13.6 for S2, N2, 12,270. Your alternative hypothesis, again, that's what we want. We want that to match what we have here, so greater than 0. Always put pooled as no. We're never going to pool our samples, so put that as no. Go down to calculate, and then we can see that up at the top here, T is 6.72, p-value very small, 9.8 times 10 to the negative 12th. And then you can see this degrees of freedom, 5,067 degrees of freedom. We're going to write down that number because we did not calculate that by hand. Okay, so I think that's what I have down here. Those are those same numbers that we got. using the calculator. So again, report your T, your P value, and your DF value. So 3 things to report there in step 3. Okay, so then that P value is less than alpha, so we're going to reject the null, giving us significant evidence to conclude nurses who increased red meat consumption had a higher mean weight gain than those that did not. All right, so I did the t-test. I did not do an example of a t-interval, but it does follow pretty closely. Let me just also show you that t-interval real quick. So if I did want to do an interval for this problem, in step 3, I would go down to 2samp t. Make sure you hit the t-int, not z-int. So 2samp t-int. And then if I just put in stats, it has all of the same things. If I were doing a 95% confidence interval, I'd put my confidence level as 0.95. Keep pooled again as no, hit calculate. And then this would give me that confidence interval. So we would be 95% confident. The interval 1.4 to about 2.6 pounds represents the difference in the mean weight gain between the nurses who maintained, or the nurses that increased their red meat consumption, and then the nurses that didn't. So that's kind of how I would go about doing that t-interval. Okay, so that brings us just about to the end here. Textbook homework. These problems are based on what we just did. You have 2 4-step problems to do there. You can hold off on doing these problems. These will be in the day 2 lesson. And then for tutorial videos, so the tutorial videos, these 4 videos go through the t-interval for mu1 minus mu2. I did not do an example of that one, so those might be helpful videos to watch. The 2-sample t-test for mu1 minus mu2. This was the example that I just did, but these give you some videos to look at it for the t-test if you want. And they are kind of split up using those 4 steps. So you have hypotheses, procedure and conditions. This is kind of like a combo of 1 and 2. Step 3, step 4, and then this is the full 4-step process. Okay, so that concludes your week 5, and I'm sorry, this should have been a 5 here. Your week 5, day 1 lesson. Hope that made sense to you. Give me a shout if you have any questions. Otherwise, thanks for watching.